We have the methods of water harvesting, Unit 1. Yes, so I'm gonna start with um, the rainfed area, which is about 63% of the total geographical area of the country, meets only 45% of the total food requirement, whereas 30% of the irrigated area accounts for 55 of the total food production. Water harvesting. Water harvesting is the collection, storage, and the conservation of any form of water, rainwater, runoff, stream flow for its productive use for irrigation, domestic and the livestock consumption, and fish rearing. There are a number of factors which impact water harvesting technology. However, rainfall is the most important parameter due to its high variability not only in time but in space. Due to highly uneven distribution of water resources, per capita water availability is highly variable, with 380 meter cube in Tamil Nadu, while in northeast it is high as 18400 meter cube in northeast due to the uneven distribution of the water resources per capita availability. The types of water harvesting systems depend on the physico-topographical condition and the pattern and extent of rainfall of the region. Therefore, due to considerable variation in the rainfall pattern and the agroclimatic conditions, different sets of water harvesting systems need to be adopted and practiced. Water harvesting techniques. In situ water harvesting techniques. First, we have the in situ water harvesting techniques. In situ water harvesting means harvesting rainwater where it falls in the soil profile. Soil and water conservation measures fall under this category. The semi arid and the arid areas where water is scarce mainly rely on the rain-fed agriculture. Therefore, in these areas, there is an urgent need to develop rainwater management skills suiting local conditions to improve water use efficiency and increase productivity. These innovative in situ water conservation techniques combine the advantages of the water harvesting and mulching and thus have the potential to reduce total runoff and soil evaporation considerably. This leads to increase in the crop productivity due to increased plant available water in the rain-fed areas. The following soil moisture conservation techniques are generally used under rain-fed conditions: contour bunding, bench terracing, contour trenching, nala bending, contour vegetative barriers. First, we have the contour bunding. Okay, contour bunds are the small embankments constructed along the contours. The contours refers to the lines joining the points of same elevations or the heights across the slope of the land at certain intervals depending upon slope and amount of rainfall. Do you observe the contours and the bunds in the diagram? Let us try to understand their significance. Bunds reduce the length of the slope, resulting in the reduction of velocity of surface runoff. Runoff is stored between the bunds, which seeps into the soil. Contour bunding is suitable for 2 to 8% land slope. In low rainfall areas, contour bunding is suitable as all the rainfall received can be stored between the bunds. However, in the medium and the high rainfall areas, all the rainfall received may not be stored between the bunds, laid at a rate of 0.2 to 0.5%. Next, we have the bench terracing. Bench terracing involves the construction of the step-like fields on the hill slopes along the contours of the half cutting and half filling. Okay, long uninterrupted slopes can be transformed by bench terracing into several small protected platforms to be used for cultivation. Bench terraces help reduce the velocity of runoff water by thereby minimizing soil erosion. In hilly areas, rice is cultivated on bench terraces by harvesting water and thus enhancing soil moisture. Bench terraces also help improve fertilizer, manures application efficiency, and adoption of the proper water management. Then we have the contour trenching. Okay, it is the process of constructing continuous or staggered trenches along the contours on the slopy field in order to intercept and infiltrate runoff water into the soil. Contour trenching is done particularly on the land with steep gradient having shallow soil depth. In medium to high rainfall areas, trenches should be continuous with zero point 0.2 to zero point 0.5 slope as in case of the graded bunds. In low rainfall areas, trenches may be discontinuous and arranged in the staggered manner. Then we have the Nala bunding. Surface runoff flows down through the natural drains, resulting in the considerable water loss. In order to use water flowing in the drains, a cemented or rock dam may be constructed across the Nala to check the flow of runoff water. Due to the bund, ponding of the water at the upstream takes place and the level of the flowing water is raised, resulting in the enhanced groundwater recharge which can be used for irrigation purpose. The water level in the nala is generally kept lower than the field to be able to irrigate and velocity of flow maintained high so as to provide less opportunity time for groundwater recharge. Then we have the counter vegetative barriers. Counter hedgerow technology provides an option for the sustainable farming on the hill slopes. The hedgerows, which are the vegetative barrier, are established by the planting of the fast growing and the deep rooting leguminous, trees or shrubs such as Leucaena, Leucocephala, Gliricidia sapium, Erythrina, etc. Along the contours on the hill slope, crops are planted between hedgerows. In alley cropping, food crops are planted within the contour alignment hedgerows of fast growing trees. Trees are pruned periodically to provide mulch and green manure to maintain soil fertility and minimize shading effects on crop. The alleys check the soil loss through cover effect, reduce runoff, maintain soil organic matter, and enhance soil moisture. The hedgerows also help in progressive development of terraces through accumulation of eroded soil on upslope of hedgerows. Vegetative barriers can also be established on contour bunds to help stabilize bunds against rainstorms by stems and roots. So far, we have learned the in situ techniques of water harvesting. We shall now study the surface water harvesting techniques. We have the surface water harvesting techniques, traditional methods or structures. India is known to have rich history of using traditional water harvesting systems based on the ITK, which is the indigenous traditional knowledge in almost all the regions. Surface and groundwater conservation is being practiced in India for many centuries. The ponds and the tanks have been important community resources for drinking water in rural India from time immemorial and remain so even today. Their sustenance can be attributed to the sound scientific knowledge and the method involved. However, many of these traditional practices were discarded during and after the British rule. The storage of even scanty rainfall through these structures has served even the arid regions of the Gujarat and Rajasthan very well. Some of the water harvesting structures being used in different parts of the country are. We have the tanka in the deserts of Rajasthan, well or kun type structure are built underground in almost every house, near schools, religious places, and farmers' field. These structures are used for collecting rainwater, which is used by human and livestock for drinking. The catchment area is specifically prepared by plastering a mixture of clay, silt of pond, coal ash, and gravel to collect more runoff water in the tank constructed for the purpose. The top of tanka is covered with a mat made of local grass. In religious places and schools, pakka roof is prepared. Khadin is also called the dhora, is an ingenious construction designed to harvest surface runoff water for agriculture, particularly in very low fall areas of the Jaisalmer district of Rajasthan. It constitutes an earthen embankment or bund 100 to 300 meter built across the lower hill slopes by lying below gravelly uplands. You can also observe that sluices and spillways are provided to drain off excess water. The Khadan system is based on the principle of harvesting rainwater on the farmland and subsequent use of this water for providing life-saving irrigation to crops. Then we have the bandaras. Bandaras is another traditional system of water harvesting for irrigating crops, especially sugarcane in Maharashtra. These structures are also very useful to control floods during heavy rain. A system where vents has been developed. The shutters are provided which are kept open during heavy rainfall. Surplus water passes through gates which help in the avoiding floods. Bandaras is another traditional system of water harvesting for irrigating crops especially. Then we have the ahars. These water harvesting structures are generally found in the East UP and Bihar. Ahars. This system based on slope is similar to Khadin. The bunds are constructed with the 1:3 ratio of the upstream and downstream slope. The earthen bunds are about 3 meter high. A lot of water is collected behind the bund. A spillway is provided to release surplus water and avoid damage to earthen bund. Concrete or cast iron pipes with diameter of 15 to 30 centimeter are fitted in the bunds at an interval of 60 to 80 meter distance for irrigation purposes. Gates are also provided. Gates are also provided to drain out water from the bund in sufficient quantity for pre-sowing irrigation. Johar are the small earthen check dams used to capture, conserve rainwater and improve groundwater recharge. In recent times, a large number of the Johars have been revived, resulting in rise in groundwater levels and increase in the forest covers. In Rajasthan, this has resulted in the dry rivers flowing with the water. And we have this Saza Kuwa. It is an open well with the multiple owners. Is the most important source of irrigation in the Aravalli Hills in Mewar in eastern Rajasthan. The soil dug out during well construction is used to construct a huge circular foundation or an elevated platform sloping away from the well. Elevated platform is used for rehat and the sloping platform is used for the chora drawn by buffaloes. Rahat is a Persian wheel consists of a chain and a row of buckets mounted on an open spoken spoke drum and provided with a suitable driving mechanic during its operation. The buck drum revolves, causing the buckets at the lower end of the chain to get filled with the water and carried to the top with their open mouth upward. The buckets get filled by into the water into the well. Kund or Kundis has a saucer shaped catchment area that gently slopes toward the center where the well is situated. It looks like an upturned cup nestling in a saucer as shown. Okay, these structures harvest rainwater for drinking in that hard desert. In Rajasthan and Gujarat, a wire mesh across water inlets prevents debris from the falling into the well pit. The sides of the well pit are covered with the lime and ash. The most pits have a dome shaped cover or at least a lid to protect the water. The depth and the diameter of the cones depend on their use. And we have the quays or barries. These are 10 to 12-meter deep pits dug near tanks to collect the seepage in Rajasthan and can also be used to harvest rainwater in areas with the meager rainfall. The mouth of the pit is usually very narrow so as to prevent the collected water from evaporating. The pit gets wider as it burrows under the ground so that the water can seep in into a large surface area. The openings of these entirely kacha earthen structures are generally covered with the planks of wood. And we have the bowries or burrs. These are community wells in Rajasthan used mainly for drinking. Most of them are very old and hold water for a long time because of the almost negligible water evaporation. Jalaras are rectangular tanks in Rajasthan and Gujarat used for community and religious purposes. Jalaras are groundwater bodies to ensure easy and regular supply of water to the surrounding areas. They collect seepage of a talab or a lake located upstream. Its water is used only for community bathing and the religious rites. We have the Kere. Tanks called Kere in Kannada were used for the predominant traditional method of irrigation in the central Karnataka plateau. In these technique, the tanks built in series of few kilometers apart are fed either by the channels branching off from Anicus built across streams or by streams in the valleys. The outflow from one tank supplies water to the next and so on. This ensured no wastage through overflow, and the seepage of a tank higher up in the series is collected in the next tank in the downstream. Then we have the power system. Power technique of rainwater harvesting known as Patali Pani is the most predominant form of rainwater harvesting in Rajasthan. In this technique, rainwater flows from the agar, which is the catchment, and percolates into the sandy soil. The quays or barriers, that is 5 to 12-meter deep, are dug in the agar, which is a storage area, to facilitate percolation. The structure is constructed using masonry technology. It's known as the Patali Valley, the most famous in Rajasthan. Areas in Kannada. Then you have the Airy. The approximately one third of the irrigated area of Tamil Nadu is watered by the Aries. Tanks have played several important roles in maintaining ecological harmony as flood control systems, preventing soil erosion and the wastage of the runoff during periods of the heavy rainfall and recharging the groundwater in the surrounding areas. The presence of the areas provided and the appropriate microclimate for the local areas. Without areas, paddy cultivation would have been impossible. Then we have the Kuls. Kuls are the water channels in the mountain regions carrying water from the glaciers to villages in the Spiti Valley of the Himachal Pradesh and Jammu. In muddy terrain, it is lined with rocks to avoid clogging. Then we have the runoff water storage structures. Once rainfall in the form of the surface runoff has been harvested, it needs to be collected and stored properly in different water storage structures in order to use the valuable resource efficiently. Stored water can either be used for multiple purposes such as life-saving irrigation, domestic and the livestock use, and fishery, or can be directed to recharging groundwater. Water can be stored either in the dugout ponds or storage tanks and diversion bunds or channels. And we have the water harvesting pond or storage tank. The ponds or storage tanks should be constructed at lower or middle reaches of the hill slope in order to receive runoff from the catchment during monsoon season. The size of the ponds depends on the amount of rain, annual rainfall, and the area of catchment. Generally, dugout cum embankment ponds are constructed in hilly areas for collection of runoff. The size of the pond is decided mainly on the basis of the water requirement and the catchment area. The storage capacity should at least be two times the total water requirement to take care of the evaporation and seepage losses. 100% extra storage may be provided for sediment deposition. Embankment type of ponds are created by constructing a small length of dam across a water course, whereas dugout cum embankment type of pond can be created by excavating a site surrounded by the hillocks from two or three sides and making the embankment from excavated soil on the remaining sides. Depending upon the site condition, Storage earthwork ratio of the 5 to 20 can be achieved for embankment and dugout cum embankment. In flat areas, dugout ponds are constructed with the storage earthwork ratio of the around 1 is to 1. Then we have the diversion bund or channel. Runoff from a catchment ultimately flows out of the catchment through a network of drains. This water can be harvested by diverting it into a storage structure or to a field to increase soil moisture. In the same way, seasonal and the perennial streams are also diverted for beneficial use. Diversion of the stream can only be achieved by constructing a bund and or channel in the catchment. Even overland flow can be diverted to a desired location by constructing bund made of soil, stone, or cement concrete. Then you have the water spreading. The flowing water is spread over large area in order to recharge groundwater. Water spreading can also be achieved by diverting the flowing water to a earthen pond or natural depression, which serves as the percolation tanks. Water is essential for life, and its proper use is crucial for its long term sustainability. The rapid pace of growth of population and the consequent urbanization has put considerable stress on available water resources. Due to the overuse of surface supplies and overexploitation of groundwater, water scarcity is posing serious problems for human existence in the entire world in general and the South Asian countries in particular. In India, availability of the fresh water is highly limited and too inadequate to meet the water requirement for different users. In large parts of the country, fresh water is being overexploited, which means that groundwater withdrawal for far exceeds the recharge from the different sources. As a result of this, groundwater levels have declined to such an extent in several parts of the country that further groundwater development is no longer feasible. Rooftop rainwater harvesting is an ideal and the efficient practice for recharging depleting aquifers in urban areas and providing water for different purposes, including drinking. This practice is being used extensively in major and urban areas of the country. Several state governments have taken measures to make this practice mandatory. Different aspects of the rooftop rainwater harvesting have been treated in the sufficient detail. Water harvesting for crop production. Uh, Water harvesting and storage surface ponds. The pressure ensures the availability of the water during water scarcity periods for domestic and the livestock consumption and crop production. A part of stored water is used for recharging groundwater also, which can be used subsequently for supplemental. In low rainfall areas, in situ stored water can be efficiently used for providing life saving irrigation to crops under rain fed conditions. Rainwater harvesting thus plays a vital and significant role in increasing food production under such conditions. The various aspects of the consumption of harvested water for crop production have been adequately discussed. Then we have the bench terrace. It means it is a level or nearly level platform constructed along the contours of half and the half filling on the hill slopes. It is defined as the area which drains water to a single point. The area is called catchment of that point. Contour is the line joining the points of equal elevation above the mean sea level. Contour bund is a small embankment constructed along the contours of the land at certain intervals depending upon slope and amount of rainfall. Contour hedgerow is a line of closely spaced shrubs and trees species planted and trained to form a barrier on the contour. Contour trench is an open drain of small cross section constructed along the contours on the slopy field. Groundwater recharge is a hydrological process of addition of surface water by way of its movement below the ground and meeting the groundwater, resulting in an increase in groundwater table. It may be defined as harvesting rainwater where it falls in the soil profile. Runoff is that portion of rainfall reaching the land surface which flows over the surface as overland flow. Water harvesting may be defined as the collection, storage, and the conservation of any form of water, rainwater, runoff, stream flow for its productive use, fish rearing. Where is charger?